All right, welcome to this explainer. We're going to do something a little bit unusual today, but honestly, it is entirely fascinating. We are taking a seemingly empty digital footprint and we're going to forensically break down the hidden machinery inside it. I mean, we interact with the web so fast these days, right? We're sending texts, dropping links in chats, pasting into shared docs, all without ever stopping to look at the actual highly engineered architecture we're leaving behind. So today we're slowing right down to look at just one. This exact string of text, along with its little heading there, is our entire source material for today. Now, it looks like digital exhaust, just a random leftover snippet from a quick message. But it is actually a perfect, completely isolated snapshot of modern web routing. This one artifact has multiple, distinct layers of technology, all stacked up and working perfectly in sync to connect you to the rest of the digital world. So, what secrets are actually hiding inside this single line of text? We copy and paste these things every single day, completely on autopilot. But for this explainer, we're treating this text like a biological specimen. We're putting it under the microscope, meticulously examining it from left to right, and figuring out exactly what it's doing behind the scenes, character by character. To do this, we'll follow a quick 5-part breakdown: the artifact itself, the secure protocol, the shortened domain, the unique identifier, and finally, the sharing parameter. Let's jump in. Okay, part 1, the artifact, or what you might call the container. So this phrase, ######, new note, is literally just a markdown heading. It indicates a fresh, blank slate where somebody dropped our specific URL. Those 5 hash symbols are telling the underlying text editor to format this line as a specific, deeply nested header. It basically sets the stage, you know? It creates the structural environment holding our code. Moving on to part 2, the secure protocol, the famous HTTPS handshake. You'll notice the link kicks off with HTTPS. This is the starting line for any modern data transfer. But that S at the end, absolutely critical. It signifies the secure, encrypted handshake established between your device and the destination server before a single byte of actual content is sent. Without that S, the entire query, including all the trackers we're about to look at, could be intercepted in plain text. Think of it like an armored vehicle safely transporting your data request across the open web. Up next, part 3, the shortened domain, youtube.b. Now, this is a brilliant illustration of how the internet evolved to handle long data strings. Instead of spelling out youtube.com, we get u2.b. In the industry, this is known as a domain hack. The engineers completely bypassed your standard .coms and intentionally grabbed the country code for Belgium, which is .b, just to save space. It's a stunning piece of micro-engineering. I mean, every single character is expensive real estate when you're pasting into character limits on social media or in a text message. Which brings us to part 4, the unique identifier, the actual routing. Look closely at this exact 11-character string right after the slash. It's the precise, unique identifier for the specific piece of content being shared in our node. Out of the billions and billions of videos hosted on the platform, this exact mathematical sequence of upper and lowercase letters and numbers guarantees the server retrieves exactly the one intended video. And actually, because it uses base 64 encoding, the platform can generate over 73 quintillion possible combinations with just those 11 characters. That is enough to assign a unique ID to every video ever made, forever. No way, right? What's really fascinating here is how that identical 11-character code remains the functional core of the request, no matter what wrapper you put around it, whether it's buried in a long standard link using a watch $V command, or it's streamlined perfectly into our shortened artifact. That 11-character sequence is the absolute heart of the request. It's the exact coordinate where the neighborhood routing finally points to a single front door. All right, part 5. This is where it gets really good. The sharing parameter, the tracking payload. We've got a question mark, followed by sigh, an equal sign, and then this long string of random-looking characters. This trailing data acts almost like an encrypted tracker module bolted directly onto our video ID. Now, you could delete this entirely and the video would still load perfectly fine, but it is absolutely necessary for the platform's massive underlying data ecosystem. Let's break it down piece by piece. That question mark? That is the web's universal invisible messenger. It tells the server, hey, hold on, the address is finished, but I have some extra instructions for you. It initiates a query string, and that size specifically stands for source identifier. It explicitly flags to the receiving server exactly where, how, or by whom this specific share originated.
Which brings us to the payload itself. This 16-character alphanumeric string, starting with NIGK, is a highly unique signature appended to our source note. And here is the kicker. It is dynamically generated at the exact moment the original user hits the share button. It's not a static piece of the video. It's a live, digital fingerprint of that specific sharing action, encoding a ton of invisible context into a tiny string of text.
So instead of just routing you to a video, this final parameter executes all these silent background functions the absolute second the link is clicked. It identifies the specific share source, it tracks user distribution journeys across the web, and it silently collects engagement data to map out how content goes viral. When someone clicks the link in that new note, the server doesn't just know what video was watched. It knows exactly which share action brought the viewer there. It's building this massive, complex web of how we distribute information.
44. That is the exact number of characters in our URL. It is just astonishing to realize that all of this complex machinery, the secure cryptographic handshake, the domain hack routing, that precise 11-character video ID, and the dynamically generated 16-character tracking payload is packed so efficiently into just 44 characters. It is literally a masterclass in data compression and network engineering.
Because as we've seen throughout this explainer, a simple URL is never just a destination. It's a highly engineered piece of code, it's a detailed map of your digital footprint, and it's a silent participant in the web's massive data economy. So the next time you copy and paste a link into a note, a text thread, or an email, maybe take a second to read it left to right. You might just be surprised by the invisible baggage you're bringing along. Thanks for exploring this digital artifact with me.